If you didn't do the quiz, sheepishly hang your head in shame. Yes. Got it done? You didn't do it? So you're going to try it yourself, mark it yourself later. Don't fill it out as we go. That would be dumb learning.
I do it for next week.
Yep. And you'll mark it yourself and hand it in. Good old Ann. An airplane turns a complete horizontal circle in 2 minutes. If the plane's speed is 170 meters per second, what's the radius of the circle? Well, they gave me the period. It's 120 seconds, 2 minutes. They gave me a speed. Oh, I said, you know what? I can do this. Centripetal speed is 2 pi r over the period. So I just got to get the r by itself. I guess r is going to be the speed times the period divided by 2 pi. It's going to be the speed times 120 divided by 2 pi. I have no idea what the answer is. Did you all get 3,250? And at first I got a bit nervous because that seems big, and then I went, wait a minute, it's a plane. It's doing a circle, 2 whole minutes. This circle is about 3.2 kilometers of radius. Yeah, I'm okay with that actually, because it's not like it's turning on a dime. It's an airplane, probably a big jumbo jet or something. Okay. What's the centripetal acceleration of this plane? Now, no matter what, I'm going to have to use the radius, so I chose to go with v squared over r. You could also have gone with 4 pi squared r over t squared. Ryan, the only reason I picked that one is literally less typing. 170 squared over, I'm going to write 3,250, but you all know I'm going to use my answer button. 170 squared over answer button. You got a centripetal acceleration of 8.9? You're pulling about a g. You'd feel a tiny bit lighter. Meters per second squared. For 2 marks, by the way, it would probably be something like this. Half mark if I saw that, half mark for rewriting it, half mark for the numbers, and a half mark for the answer here. Probably 1 mark for that, half mark for the numbers, half mark for the answer. Number 2 wants the centripetal force. So centripetal force is MAC. The real question is, which version of A am I going to use? Well, they didn't give me a speed. They gave me a frequency of 5. That means the period is 1 over the frequency. It's 1 over 5, which is, I'm pretty sure, 0.4, I think. 0.2, 0.2. 0.2, I said, 0.2, I think. Wow, where'd that come from? And so now I can go FC equals M4 pi squared R over T squared, M 12 4 pi squared 6 all over 0.2 squared. And this question made me nervous at first. I got a huge answer. You get 71,100 if I go to 3 sig figs, 71,060. And I went, holy smoke, 71,100 newtons. That's massive. But then I went, wait a minute. What's the mass of this question? 12 kilograms, a little more than 25 pounds. Think really a heavy bowling ball or a medicine ball. What's the radius of this question? 6 meters is about from me to Ryan. How many times a second are we spinning it? 5 times every second. So we're spinning with a radius of 6 meters a bowling ball 5 times a second. Yeah, that's going to take a lot of force. So that actually made me more comfortable once I looked at it and went, Actually, no, it should be a huge answer. You would not want to be in the way of this. It would not be a survivable experience. Number 3, a belt passes over a wheel of radius 25 centimeters. They want the centripetal acceleration. Matt, did they give me the speed or the period in number 3? I'm going to use the v squared over r. And they just want the acceleration, so I don't need to multiply it by the mass. They could have also asked for the force, but I would have needed the mass of the belt or something, which is a little awkward. So yeah, it's going to be 5 squared divided by 0.25. Oh, this is 25 divided by point. Is it 100 even? That's nice. Cool. Next page. Now we started to get into some of the physicsy questions. So Ferris wheels and roller coasters, you can absolutely expect. In fact, between Ferris wheels, roller coasters, and gravitrons, you can expect 2 out of those 3, probably, because I'm nuts about amusement park rides. It says a Ferris wheel has a radius of 9 meters. It wants the force the bench exerts on the person at the top of the Ferris wheel. I did a quick rough sketch. I just did that, and then I drew my free body diagram. I said gravity down. Normal force on a Ferris wheel is always pointing up. How did I know to draw the normal force smaller than mg? What path are we tracing out? A circle. Where is my winning bigger force pointing? Toward the center. And so I ended up with mg minus fn equals m. Matt, did they give me the period? 4 pi squared r over t squared. M cancels? No, actually, we'll all feel different normal forces. All of us will experience an amusement park ride differently. I think I've said, as you gain mass, as you get older, you may find that stuff you could go on when you were 8 years old, you can't go on it when you're 19 years old. It's different physiological feelings. Anyways, I'm going to do the swappy dance to get the Fn by itself. And I'm going to get mg minus m 4 pi squared r over t squared equals Fn. Got more room? Good. The normal force is going to be m, 65, g, 9.8, minus 65, 4 pi squared, oh, r is a number, Mr. Dueck, 9, all over t squared. No idea what the answer is here. 65 times 9.8 minus 65 times 4 times pi squared times 9 divided by 25 squared. Did y'all get, 600 almost even? Is that right? Repeat for the bottom. So I said, okay. For part marks, by the way, if you got that right, 3 out of 3. Otherwise, I would probably give you 1 mark if I saw that line, 1 mark if I saw that line, half mark for the numbers, and a half mark for the answer, something like that. What's the force at the bottom? So I did a quick there. Gravity down, normal force up. Ethan, why did I draw the normal force so much bigger? What path are we tracing out? Where is my winning bigger force point? This is the key for centripetal force. Come on in. Pause the video for 1 second. So my equation here is going to be normal force minus mg equals m 4 pi squared r over t squared. I'm going to get normal force equals mg plus m 4 pi squared r over t squared. Oh, that's convenient. Copy. Paste. Plot. Oh. Plus. Oh, that's convenient. Backspace. Paste. Plus. Second function, enter, will bring back, every time you hit it, it'll go one line back. I think it'll remember 30 lines on the TI. That's really handy. I use that all the time. Is it 674? Correct answer, 674 newtons, yes? What was the normal force at the top? 600. What was the normal force at the bottom? 674. Is there a big difference? Ferris wheel's a tame ride. Really, another way to talk about how intense a ride is to look at the difference in normal forces between top and bottom. Yeah, that's really handy. Whatever you've hit most recently with the enter key, that's the answer that is now stored in that answer button feature. So I can show you, you're in calculus. You haven't yet done recursion Newton's method, but once you do recursion Newton's method, there's a way, you don't type it in with numbers, you type it in with answer buttons everywhere there's an X, because what you're going to do in Newton's method is you use your first guess to find an answer, plug that answer back into the same equation to get a better answer, plug that answer back into the same equation to get a better answer, and on some calculators you have to retype it every time, but on those, as long as you just put an answer in for the X, once you've typed it in once, you just hit answer, 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 and each time it's plugging in the previous answer, and you'll find after hitting enter about 6 times, you'll be accurate to about 9 decimal places, which how much more accurate you need to be. It's a cool trick. Meanwhile, oh, roller coasters! Woohoo! Number 5. At the top of a roller coaster loop of radius 11 meters, a 75-kilogram rider experiences a normal force of 4.5 times their weight. This here is really the key phrase to understanding this. Of course, Matt, this is a job for us. What are the forces acting on it? Get the obvious one. What else? Normal force. Which way? On a roller coaster, it's always the way your head is pointing, so there's also a normal force pointing down. In which case, I don't have winner minus loser. I have winner plus winner. In fact, I'm going to get this. Normal force plus mg equals m. And since they're asking for speed, I went v squared over r. I don't know the normal force. Yeah, I do. It's 4.5 times the weight. What's the equation for calculating an object's weight? No, now. What's weight? Yeah, it's going to be 4.5 mg plus mg equals mv squared over r. You could cancel out the m's right now. I actually, before I noticed that there was m's and everything, I noticed that these were like terms. I said, you know what 4.5 mg's plus 1 mg is? I said, this is actually 5.5 mg's equals mv squared over r. I said that, and then I said, oh, I'm going to times the r over, and I'm going to get a square root of GR with some other stuff, but there's my old familiar friend letting me know that I'm probably doing this right. I said, v is going to be the square root of 5.5 GR. And the reason it's 5.5 and not 4.5 is all of you right now are feeling 1 times your weight. That's your normal. So if you want to feel 4.5 times heavier, we have to bump it up to 5.5, and it's that extra 4.5 that makes you feel heavier than your normal. You had a question? Okay. It's going to be 5.5 times 9.8 times 11. 5.5 times 9.8 times 11. Second function, square root answer button. 24.3 meters per second times by 3.6. Oh, that's not bad. Doing 90 kilometers per hour at the top. I'll go on that. If you got that right, 4 out of 4. Otherwise, I would probably go 1 mark for that, 1 mark for that, 1 mark. I'd probably go actually 1 mark for that, half mark for the numbers, and a half mark for the answer. But if you got it right, that's fine. After the first loop, the riders hit a second loop At the top of the second loop, the rider is traveling at 16 meters per second, and they feel a normal force of twice their weight. I think it's the same free body diagram at the top, so I wimped out. I went like this. Copy. Paste. But now we want the normal force to be twice their weight. So it's going to be 2, oh, change colors, Mr. Dueck. 2 mg's plus mg equals mv squared over r. So I'm going to get 3 mg's equals mv squared over r. Again, the math cancels. Little kids and grown-ups can go on this. This time they wanted the r by itself. I think r is going to be v squared over 3g, I think. It's going to be 16 squared all over 2 times 9.8. 16 squared all over 2 times 9.8. You get 13.1? Why did I write a 2? I don't know. Let's try that again, Mr. Dueck. Did you all get 8.71? Sheesh. And that's a radius, meters. This one. Okay. Because you're all experiencing one normal already. If you want to feel twice your weight, sorry, I have to actually add 2 more normals, which makes a total of 3 normals. Right? 1 mark for that. Again, I'd probably go, oh heck, 1 mark for that, 1 mark for that, 1 mark for the answer. Something like that. But if you got it right 4 out of 4, can you give yourself a lovely score out of 23, please? Last day we looked at the, where am I going? More horizontal circles. We looked at artificial gravity, and I told you I like that question. So we looked at how you could spin a space station to create artificial gravity. Very cool. We noticed that as the radius decreased, the fake gravity got less and less, and we concluded there would be a band in the middle right along the axle where gravity would be 0. You would feel weightless. We looked at the gravitron, a ride that spins you around really, 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 really fast, and we noticed that for that one, friction was kind of important. We looked at spinning mass on the end of a string, and then we looked at the banked corner. We said that for the banked corner, friction was not important. The reason we bank corners is because that way, even on a snowy or an icy day, if you do the speed limit that it says for you to do, you will take that corner safely. And then if you do add friction, it actually gives you a range of speeds if you wanted to dive into that. But I'm not going to give you friction on a banked corner. The reason this banked corner was so weird, though, was because there was an angle. Did I say angle? No components. We said this time, no components. And we got to example 6. Here's a good question. You're an engineer and you're asked to design a racetrack. You have a banked corner, and the biggest you can make the radius is 165 meters. And you want the drivers to be able to take the corner at 45 meters per second, which is pretty fast. At what angle theta do you need to design the track? Okay. It's a banked corner, so I would first of all dulp. I'm going to draw a little picture. So here's a side view of my banked corner, and apparently what I'm looking for is theta. I'm not going to draw the car. I'm going to represent it with a dot. And remember, the key idea we said, the reason we said we don't need to go components for the banked corner is because the circle that the car is tracing out is a horizontal circle. So it would be better not to do components this time. You could, it's just a lot more work. What are the forces acting on it? Get the obvious one. I haven't done the diagram yet. Patience. What are the forces acting on it, Adam? Get the obvious one. And normally we would have stopped and broken this up into components, but I said specifically for the bank corner. And another question we're going to look at today that's an identical diagram. We're not. What else? That's a lot, well, whatever. 90 degrees from the surface. We said that's it if we ignore friction. We said rather than go components, Matt, we're going to combine these two vectors. We're going to add them together. How would I add them together? Draw them. Draw the easiest one first, which is gravity. And then from the tip of gravity, how did I know that I had to stop exactly right there? Why don't I go further? Why don't I go less? What path are we tracing out? So where must my combination net force be pointing? Toward the, and since it's a horizontal circle, I knew that FC would be dead horizontal. Adam has been waiting for color, 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 and we said that that was that angle. Theta is down there. Typically, I'll use tan, I'll use gravity and FC. Now, why is that? Because if they don't give me the mass, I know the M will cancel there. I don't know the normal force, although I could probably write it as some kind of a perpendicular component, but then I'd have a trig function inside of a trig function. I'm going to use tangent. Opposite, adjacent. What we ended up with was this. The tangent of theta equals opposite over adjacent. Now, last day, we got the FC by itself because we were wanting to find a speed which was hidden inside of the FC. Haley, what's this question wanted me to find? I'm going to go shift tan. But I have to tidy up the right-hand side just a little bit first. FC is mv squared over r all over mg. This is a three-level fraction, which is a little bit tricky to read. So maybe you might have felt better in your mind seeing it like this. mg tan theta equals mv squared over r. You could have moved the mg over. I think it was August who told us to do that last time. I can't remember. You could have just done it that. It was somebody that I picked on. Anyways, can you see the m's cancel? And the g ends up on the bottom. From this line here as well, the m's cancel, and the g just ends up there. We get a GER, although we're not going to get the square root of GER because we're not trying to find v. We end up with this. Tan theta is v squared over GER. What was v that we wanted this to go at? I've scrolled down. How fast? Sorry? That's what we want cars to be able to go at. Divided by g, and was r 165? So if I go, g is 9.8. If I go 45 squared divided by bracket 9.8 times 165, I get 1.252. What? Huh? What is that? What have I just found? I found the tangent. In other words, on my next line, I would say to myself, tan theta equals Adam. You're going to say that in 1 second. 1.2523 dot, dot, dot. How would I find theta? Shift tan of that. What angle do I want to bank this at? Pretty steep, 51.4 degrees. What's a racetrack? This would be difficult for a human to walk on. Most of you have never been on really, really steep angles. A couple of summers ago, I purchased a sailboat, and so I'm starting to learn how to sail. And sailboats, when the wind hits you from the side, your boat heels over. And I've been in my sailboat, and I swear I'm at a 45 or 50 degree angle, but I have an inclinometer, 16 degrees. But my body is not used to heeling over at all, and so just a 16-degree angle, honestly, is terrifyingly steep. You're bracing your feet on the far side. I've gone out with a friend of mine, and he regularly puts his boat over to 60 degrees, and it's terrifying because we're not used to heeling over at an angle, but it's perfectly safe. So these angles to walk on would be difficult. Even in the previous question, the first banked corner where I had the angle of 23 degrees, I don't think that would get through as a regular city street. They pretty much 6 degrees, 8 degrees, maybe. Okay? So, theta equals the inverse tan of 1.2523, which was 51.4 degrees. You don't have to write that if you don't want to, but somehow in your notes, please make sure that you know that we did shift our second function tan. Did I show you these videos yet? Juggling in a cone, Centripetal game, and India Wall of Death? Did I show you those or not? No, okay. Homework. Number 1. Number 2 is good. Number 3 is good. Four is good. 5 is good. 6 is good. You gonna sign everything? Maybe. 7 is good. So here's some banked corner questions. So 8 is good. 9 is good. I'm going to give you an angle question in the homework, number 10. I'm not going to ask you to find an angle on the test, but it's a good review of remembering how you do find an angle theta by going shift sine or shift cos, or in this case, shift tan. So I'm assigning 10. 11 is good. 12 is good. Are you assigning every question? I guess I just did, Mr. Dueck. I was going to try and get on to the next lesson. I'm going to pause because I got some cool videos to show you.